So here we are going to discuss about the next type of matrix, which is the scalar matrix. Okay, a scalar matrix is a square matrix. Okay, square matrix means that the number of rows is equal to the number of columns, with all the principal diagonal elements or leading diagonal elements being equal. Okay, so it is a square matrix with all the principal diagonal elements being equal. Okay, all the elements which are present in the leading diagonal or principal diagonal must be equal. So an example of a scalar matrix is, let's say, in general form A 0 0 A. Okay, see here, the principal diagonal elements are equal, and the other definition of a scalar matrix can also be that it is a diagonal matrix with all the principal diagonal elements being equal. Okay, it is a diagonal matrix with all the principal diagonal elements being equal. Okay, it is a diagonal matrix. Another definition which we can add here is that it is a diagonal matrix with all the principal diagonal elements being equal. Now we have already studied what a diagonal matrix is. In the diagonal matrix, all the elements except those being present in the principal diagonal are 0. Okay, so here the elements except the principal diagonal elements are 0, and the second condition which is added here is that the principal diagonal elements are also equal. Okay, so a scalar matrix is a diagonal matrix with equal principal or leading diagonal elements. Another example, let's say 4 0 0 0 4 0 0 0 4. Okay, this is also a scalar matrix. See, the principal diagonal elements are equal and all the other elements except the principal diagonal elements are 0. So it is a diagonal matrix and also the principal diagonal elements are equal, so it is a scalar matrix. Okay, so a scalar matrix is also a diagonal matrix. Okay, because all the elements except the principal diagonal elements are 0. Now an important thing is that every scalar matrix is a diagonal matrix. Okay, every scalar matrix is a diagonal matrix, but the vice versa may or may not be true. Okay, every scalar matrix is a diagonal matrix, but the vice versa may or may not be true. Every diagonal matrix may or may not be a scalar matrix. Okay, because even though a matrix is diagonal, that is only the principal diagonal elements are non-zero and all the other elements are 0, it is diagonal. But if the principal diagonal elements are not equal, they may be unequal. Here in place of 4 4 4 we can write 1 2 and 3. It will be a diagonal matrix, but it will not be a scalar matrix. So for a matrix to be scalar, all the elements in the principal diagonal should be equal. Okay, they should have equal value. So an important point is that a scalar matrix can be a diagonal matrix, but a diagonal matrix cannot be may or may not be a scalar matrix. Okay, so the next matrix which we are going to study is the unity matrix or identity matrix. Now, a identity matrix or a unity matrix okay, this is a very important matrix which is used in the handling of various types of matrix operations, especially in the calculation of eigenvalues of a matrix. We will go to that. That is a separate topic, but it's a very important matrix. Okay, so the unity matrix or the identity matrix, or it is also called as unit matrix. You can call it by whatever name you want. Okay, the unity matrix is a scalar matrix. Okay, it is a scalar matrix. So by default, it is also a diagonal matrix. As it is a scalar matrix, so it is compulsory that it should be a diagonal matrix. Another restriction which is added to unity matrix is that all the principal diagonal elements or leading diagonal elements are ones. Okay, ones. Here all the principal diagonal elements are 1. Okay, so a unity matrix of order 2 is given by this 2 cross 2 unit matrix. Similarly, a 3 cross 3 unit matrix can be written as this. This is a 3 cross 3 unit matrix. Similarly, we can design a 4 cross 4 unit matrix like okay, this is a 4 cross 4 unit matrix. Now the important feature here is that it is a diagonal matrix. Okay, it is a diagonal matrix because all the elements except those in the principal diagonal are 0. It is a scalar matrix because the principal diagonal elements are equal. The extra characteristic which is added here is that all the principal diagonal elements are unity, means 1. Okay, so it incorporates 3 characteristics. It is a diagonal matrix, it is a scalar matrix because they are equal, and the extra feature which is added here is that all the principal diagonal elements are 1. Here also the same. It's a diagonal matrix, it is a scalar matrix, and all the principal diagonal elements are 1. Here also the same. Similarly, we can design unit matrix of as many order as we want. 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5, 6 cross 6, 7 cross 7, like that. So those 3 matrix, the square matrix, the diagonal matrix, the scalar matrix, and the identity or unit matrix, they are interrelated with respect to each other. Okay, unit matrix or identity matrix is a diagonal matrix as well as a scalar matrix. Similarly, a scalar matrix is a diagonal matrix. Okay, so it's just like that, but the vice versa, it may or may not be true. For example, a unity matrix is a scalar matrix. Every unity matrix is a scalar matrix, but every scalar matrix is not a unity matrix. Okay, similarly, every scalar matrix is a diagonal matrix, but every diagonal matrix may or may not be a scalar matrix. Okay, so here we have discussed about the scalar matrix and the identity matrix. Okay, so in the scalar matrix, all the principal diagonal elements must be equal. It is a diagonal matrix with all the principal diagonal elements equal, and in the unity matrix it is also a diagonal matrix with all the principal diagonal elements equal to 1. Okay.